Mixture problems, as you'll see in Gen Chem, are basically a combination of stoichiometry, algebra, and in some more advanced cases, proportions. But in this simple introductory case, we'll just use algebra and stoichiometry. The question reads, a 4-gram mixture of NaCl and KCl is reacted with AgNO3 to form 8.5904 grams of precipitate. How much NaCl is in the mixture? First question is, okay, what is this precipitate? So let's write out these reactions. So we have some NaCl in the mixture, and that reacts with the AgNO3 to form NaNO3, because this is double replacement, and AgCl. Let's do the other reaction, KCl plus AgNO3, once again, double replacement, and this gets us KNO3 and AgCl. Now, if you have your solubility rules memorized, you should know that this is our precipitate. So now, second question, okay, we have 8.5904 grams of AgCl. How do we get our grams of mixture to grams of AgCl? So we know that we have some amount of NaCl and some amount of KCl in the mixture. So what if instead of representing it with a number, we represented it with an x? Okay, so we have x grams. Since we're trying to find NaCl, we'll use that as x to make our lives easier. And x grams of NaCl. And we can just do the same stoichiometry we did as before, right? We can do the molar mass, right? We can do 58.44 grams of NaCl goes to 1 mole of NaCl. And we can do 1 mole NaCl goes to 1 mole AgCl because of this balanced reaction above, right? Then 1 mole of AgCl goes to 1 mole of, not 1 mole, goes to 143.32 grams of AgCl. So that should all get you 2.452 x grams of AgCl. Because remember, we have x grams of NaCl. Cool. So let's do the same treatment with KCl. Well, we've already used x, and we know we have x grams of NaCl in this mixture, and it's a 4-gram mixture. So if we have x grams of NaCl and 4 grams of mixture, it reasons that 4 minus x grams of KCl must be left over in this mixture. So then we can apply the same treatment. 74.55 grams KCl gets you 1 mole KCl, which gets you 1 mole KCl over 1 mole AgCl, and then 1 mole AgCl is 143.32 grams AgCl. So all that should equal you 1.922 times 4 minus x grams AgCl, because remember this term is from this part, and then this term is from this starting part, okay? So now, cool, we know how many grams of AgCl were formed. So how do we solve for x? Well, we know the total amount of AgCl is 8.5904. So if we say, okay, the amount of AgCl formed from the NaCl is 2.452 x grams. And we know the amount of AgCl formed from the KCl in the mixture is 1.922 times 4.000 minus x all of that should equal the total amount in the mixture, which is 8.5904 grams, right? So now this is where the algebra part comes in. We have to use algebra to solve this. So we can start by distributing this term, right? So we have 2.452x plus 7.688 minus 1.922x equals 8.5904, right? And remember, this is your given grams of AgCl. Then let's keep going, right? You can subtract those two x terms and move this term to the other side. So what you end up getting is 0.530x equals 0.902. And if you solve for x, you get x equals 1.70. Cool. So if we go all the way back up to our stoichiometry step, we know we set x as the grams of NaCl. So we know that we have 1.70 grams of NaCl in our mixture.